This is Pre-Calculus A, Unit 6, Conic Sections, Lesson 5, Parabolas. So far we've talked about conic sections and what they are, that they are slices off of a two-ended cone, so to speak, with no bottom and no top. And we talked about the general form of the conic section, ax squared plus bxy, careful, capital B, xy, plus cy squared, plus dx plus ey plus f equals 0, and how we can discriminate or determine which conic section we have by the value of the discriminant b squared minus 4ac. If it is equal to 0, we have a parabola. If it is less than 0, that if it's negative, we have an ellipse or a circle. Circle if A equals C, ellipse if A does not equal C. Okay, and if it's greater than 0, we have a hyperbola. In reality, you can tell it a little bit easier. If you've got an x squared term but not a y squared term, you've got a parabola. It'll become more apparent here. The case becomes a little tougher if we start rotating the conic sections at angles other than horizontal and vertical, which we don't really deal much with in this unit. But there is that possibility of rotating parabolas and hyperbolas and all of those. Okay, so we'll stick to the discriminant rule. That said, I've got an example I want to work out here. Let's do this. I'm going to take y squared minus 6y minus 4x plus 11 equals 0. And you'll notice there's some missing terms here. So in general terms, this is ax squared. Okay, so there's no x squared. So we would say 0x squared. There's no xy term, so 0xy. There is a y squared term, so y squared. There is an x term, minus 4x. There is an e term, a y term, so minus 6y. And there's a constant, plus 11. So in this case, A is 0, B is 0, and C is 1. Okay, so B squared minus 4AC. Okay, B squared minus 4AC is 0 squared minus 4 times 0 times C, which is 1. Well, the zeros make everything 0. So this is a parabola. Okay, but the true hint here was that there is a y squared term but no x squared term. Okay, all right, so that said, let's take this parabola and let's convert it to from general form to standard form for a parabola. And I haven't told you yet what that is, but we'll bring it out here. Okay, as before, we're going to complete the square. So we're going to group the x's and the y's together. So y squared minus 6y. Okay, and I'm going to do this. I'm going to move the x term to the other side, 4x, and the constant term to the other side. Because there's no completing the square on the x has no x squared term. Okay. There's no coefficient in front of the y, so let's go ahead and complete the square. Let's see. What adds to itself to make negative 6? Well, negative 3 plus negative 3. So negative 3 times negative 3, that's 9. So I'm going to add 9 to both sides to complete the square, and we get y minus 3 squared equals 4x minus 11 plus 9, that's 4x minus 2. Okay, and now I'm going to solve for x. So we're going to solve for x. So I'm going to add 2, y squared minus 3 squared, or y minus 3 squared, not y squared minus 3. Okay, y minus 3 squared plus 2 equals 4x. I'm going to switch sides and divide by 4. So 1/4 y minus 3 squared plus 2. Okay, and this is the general form for a parabola. Let me give you the general form now. The general form for a parabola is y equals, now I'll explain the y equals and the x equals here in just a moment, 1 over 4p times x minus h plus k. Okay, this is a parabola whose vertex is hk. Okay, and we call something the directrix is going to be at, the value p has something to do with it here. The distance between the focus and the directrix, or the vertex and the focus. So the vertex to the focus and the vertex to the directrix, and I'll explain what those are in a moment. Those are p. Okay? Okay, all right, so here we go. Let's define what they are here. So let's first determine what h and k are. H is 3. Actually, h is 2 because this is oriented horizontally. This standard form is oriented vertically if it's y equals. If it's x equals, it's horizontal. Okay? And the vertex is at 2 in the x direction and 3 in the y direction. Okay? So here's how we graph it. Okay? So we're going to go to the vertex, 2, 3, 2, 3. Okay, that's the vertex. And the focus, this one is positive, so it opens to the right. If it were negative, it would open to the left. Okay, the focus is 4p, so in this case, p is 1. All right, so we're going to go 1 to the left. That's the directrix. And 1 to the right, that's the focus. Okay, 1 to the left, that's the directrix. 1 to the right, that's the focus. Okay, and the parabola is going to look like this. And here's the geometric meaning of a parabola, or the parts of a parabola. If we measure the distance from any point on the parabola to the directrix and measure the corresponding distance to the focus, they will be the same. No matter where I am on the parabola, the distance to the directrix line and to the focus is constant. Okay. Now, some interesting properties of a parabola. If I have parallel lines coming in and reflect off the edge here, all the lines of reflection will be directed to the focus. And hence you see parabolic reflection dishes used in satellite dishes, used in the sidelines of football games. You ever see them hold up a dish with a microphone in it? They're picking up sounds off the field. Okay? It's used in flashlights and headlights because if you place a lamp at the focus, the beams that reflect off the surface of the parabolic dish, will be reflected out parallel. Okay? And of course, if you move further out, they will be reflected into a point, and if you move further away, they'll be reflected out. Yeah, I had to think about that. All right, so that's how you place a parabola in standard form for a parabola from general form, and the parts of it. Hopefully that helps.